Let's review a handle on McMaster and talk about how it differs from some of the other handles that we've looked at. So I'm going to open up this McMaster item, and here we see this clamping handle with a threaded stud. And another handle that we've looked at in the past is this guy right here. So it might not be immediately obvious, but that's okay. We'll talk about it. Raf, just looking at this, can you imagine any differences about how these two types of handles work?
This one looks like a device to lock something in place, immobilize something. And this one looks like you're trying to screw something almost. I'm not very familiar with these handles. I mean, we're all familiar with the ones with open drawers, but not with these ones.
Right, yeah, so most handles are really basic, like you said. They're just static pieces of hardware that you grab and pull, and that's it. So I tried to introduce a couple of handles that are a little bit more sophisticated, a little bit more mechanically complex, and that's how we get to these ones here. And you're right that this one can be used to immobilize an object. This one can be used in the same way. So they both do similar things, but the mechanisms are a little bit different. So for example, this guy here, this spring-loaded retractable handle, right, that you can pull like that axially to engage or disengage. All this does really is rotate, and as it rotates, this surface right here will bind down against something, and I'll show you an example in just a second of how that works. But the motion here is just rotational. That's all it does. Whereas this one here, there's a cam, and so you can see that there's a pivot point right here, pivot axis, and this shape underneath that pivot axis is actually a cam. So it's kind of like, have you ever seen on a bicycle, they have these used often where in order to remove the front tire, you'll like rotate this up, and that loosens the fork that holds the bicycle wheel in the fork, and then you can pull the bike out.
I think I've seen these on the bike seats.
Yeah, exactly. Yeah. They use them on bike seats as well. Yeah, that's right. So what happens is you can use these to, you can rotate the entire thing and until it gets kind of tight, and then you push down that lever, that handle, in order to really cinch it down and make it super tight. So the difference here is that it operates on a cam. This one only rotates, whereas this one will rotate and it will fold, 90 degrees or whatever. So it starts like this, and it'll open up to something like that. And this is when it's loose, and then you fold it back down to tighten it the rest of the way. So this just, it has like an extra degree of freedom, I guess, and makes it maybe a little bit easier in some cases to tighten something down. So I mentioned that I'll show you an example of how this one works. So we're going to check out a little assembly here.
What is this program that you're using?
This is called eDrawings. It's a free viewer. Well, it's free on desktop. I think it costs a couple dollars for mobile apps, but it's a viewer that allows you to open up CAD models, so specifically SolidWorks models. I don't think it works with step files, but certainly with SolidWorks files. So anyway, that's what we're using to view this. So in this assembly here, we've got this handle, right? We've got a spring-loaded retractable handle here, and you can see it's kind of positioned like this, where this feature right here is right there. And so that face, this face here, that binds down against this face right here. And this thread, so this thread right here.
And to clarify, this bolt is not in there.
Correct. Yeah, this nut is it's stuck on there now, but this nut is just, you can forget about that. Right. So this thread goes into a threaded hole in this bracket. So the handle is attached to this green bracket by means of the threads, and because we can rotate this handle further. This face right here is going to bind down on this face right here, and essentially lock this bracket in position, prevent this bracket from being rotated up out of this groove. Right now this bracket holds gears, and the gears mesh with adjacent gears, but we wanted a way to disengage those gears. And so what we came up with was this swing arm here. And so when you disengage the handle, it no longer binds on this face, which means the entire bracket, and thus the gears can be rotated out of place and disengaged from the other gears. But when it is in place and this handle is tightened down, that ensures that this swing arm cannot move out of place. In other words, it ensures that the gears cannot become disengaged. So that's just an example of how you might use one of these handles.
Do you think you zoom out so I can see in the grand scheme of things what this is?
I shouldn't actually.
Okay, let's keep it that way.
All right.
For some reason, I'm thinking, why can't we just put like a bolt in there that just holds it in place? It'll be smaller. Why the handle?
That's a great question. Why do you think? Why might this handle be a better solution than a bolt?
I think the only difference that I'm seeing is this factor, the spring.
Okay.
Maybe it allows you to do take things in and out, because here there's gonna be pressure.
Mm-hmm.
Right there.
Yep.
But then when you move it, maybe you can move something out.
Okay. Think about how would you engage a bolt in there?
Well, I would just screw it on there.
With what? Using
like a screwdriver,
okay.
Or maybe a device that can fit in there, like an L-shaped.
Mm-hmm.
Half like this.
Yep. Some kind of driver, a tool.
Yeah.
And what about this guy? What kind of tool do you need to engage this one?
Just grab it by the handle.
Right. That's really the big benefit of using this, is it doesn't require any tools to engage it, just your hand, which hopefully you have with you.
Great. Okay, sounds good.
All right. If you found this content helpful, consider enrolling in our signature program at mypipelineacademy.com. Whether you're an individual interested in beginning a new career as a mechanical designer, or a company interested in training your new engineering hires, our signature program helps students develop the practical skills they need to be productive mechanical design engineers. Seating is limited. We hope to see you there soon.